Assalamu alaikum. Good evening, ladies and gentlemen. My speech will be focusing on the alarm handling and human factors and some of the best practices, as much as the time can allow me to do. And I'll be presenting some of the charts, or some of the charts I took from our system as a demonstration for some of the best practices. We are on a very early stage of the alarm management systems. So hopefully by the end of this project, we'll be able to achieve the targets. So as an agenda, we'll go through a small introduction, then we will be looking at why the alarm would be a problem for refinery plants or gas plants, as in our case. Then we'll be looking at the alarm management systems and the 3 steps best practice approach as described by the HSE executive. I'm listing here 4 of the major incidents that has happened in industries since 1979. The 3 Miles Island, Piper Alpha, Texas Milefield Haven Refinery, and Buncefield Oil Storage. All these incidents have one common contributing factor between all of these incidents was related to the number and design of the alarms. As a result, the panel operator missed key information that could have prevented the explosion if the design was proper. So what is an alarm in the first place? As per the standard ISA 18002, it defines the alarm as an audible and visible means of indicating to the operator an equipment malfunction, process deviation, or abnormal condition requiring timely response. The definition itself sets the main 3 parts for any signals to be considered as an alarm here. It first says that the alarm should have an audible and visible indication, and that is related to how the alarm is supposed to be presented to the operator. And then the operator is the target audience, so it has to be something that the operator can do or react to. And the third, it requires a timely response. So we are not supposed to present information to the operators where he is not supposed to take action. Now, let's go through a little bit of history. I have witnessed both cases, the first one and second one. That is during my last project in Benegas. During the upgradation project from the pneumatic panel to the DCS, we had the top picture as the old one. And we were able to operate the plant with almost 225 alarm windows. And for almost 35 years with successful production. But because of the switch from the hardwire signals to DCS, everything was available on the DCS. Everything was shifted from the local control to DCS. This resulted in a huge increase in the number of alarms, as we see on the bottom charts, which is saying that this is not a healthy condition for the operators, since the operator will not be able to handle all these alarms in the limited time and a safely manner. So let's look at some of the limitations and some of the problems that can be considered as the genuine problems why as we can say that why the alarms are considered as a problems. There are mainly two categories: the quantity and quality of alarms and the human limitation. Now the standards, or all the research is done from different organizations like IMUA, ISA, or ASIM, suggests that the yellow part of the chart is best practice for the rate of alarm that any operator can handle. But the reality is the red columns, where you can see that, for example, in oil and gas, the number of alarms appearing on 24 hours basis is 1,200 alarms per day, which is with an average of 1 alarm per minute. Now, the other factor is the human limitation, and since human is always a part of the decision-making process, there is a limitation with regards to the amount of information a human can take in, and the amount of information he needs to investigate and take actions based on that, and the amount of actions he can take in the limited time. The chart says that 40% of the accidents that happen in the industry are related to people, that is the red part of the pie chart. And the outcome was these were found to be almost always preventable, since these 40% were mostly related to procedures and lack of actions. Now, alarm management as an alarm management is, as definition, it's a process of processes and practices for designing, operating, monitoring, and maintaining alarm systems, keeping human limitations in mind. So it is it's a human-centered process, actually. And as per the HEC executive, the 3 steps, which are not the only best practice available, the ISAS puts around 6 to 7 steps, but the HEC has condensed them down to 3. And the step 1 is to find out if we have a problem, and then we have to improve the system based on our findings, and then we have to audit the systems and keep that going. So this is a screenshot I took from our system during last December. The bottom section says that the maximum manageable number of alarms per day is supposed to be 300 alarms per day. That is the maximum manageable. But we can see we were operating perfectly well from the beginning of December up to the 19th of December, and then suddenly we had a shoot in the number of alarms, and we had 467 alarms, which indicates that we have a problem. So we have to work on that. As a continuation to this, when we zoomed into that 467 alarms per day, we found that those were almost 70% of the alarms generated on 20th of December, and they were only limited to afternoon shift. And we can see that 8 hours afternoon shift here scored a very high number of alarms against the recommendation of the standards per hour, which says the maximum manageable alarms per hour is 12 hours, taking into consideration that the operator has to read the alarms, has to investigate, and has to take action, so that needs some time. But I can see at 10 o'clock, we had 83 alarms generated, so which is far above the recommendation of the standard. Now, we have done the benchmark part, and we knew that we had a problem. The next part is to improve the systems. So as part of, this is almost fixed part across all the standards. We have to set a philosophy. Philosophy is supposed to be the basis on which we will do the work. So the philosophy will involve the procedure and defining of alarms, alarm selections and presentation, and how to control the change. So you cannot leave the alarm set point change open to the operator, and how to assign priorities. In addition to that, we have to assign the responsibilities, and we have to do the trainings. So all that has to be done within the philosophy. Then we'll go to the rationalize part of the process, which is examining each tag and make sure that it really fits and really meets the criteria of the alarm definition. So we may ask questions like, does this tag meet an alarm criteria, and does it require an action from the operator? And what is that action that is required for the operator to do to prevent the escalation of the process into an ESD system? The next step now, one of the best practices here is to find out what is called the bad actors of the alarm systems, which are normally the in our case here, what I'm showing in the list are the few number of alarms that cause significant amount of alarms activation, which was the source for the 83 activation of alarms at 10 o'clock, and provide normally these 10 bad actors are easy to handle, and they provide low-hanging fruits and gives a huge and instant enhancement to the alarm systems. So if you look at the first tag, this tag was FI7 was a source of 162 activation of alarms during the 8 hours, which is totally unacceptable. And we wouldn't accept an operator to be able to handle this number of alarms within 1 hour. Then the other best practice is to use a consistent, clear, concise messages. That is, it will be most probably the best practice is to use the same abbreviation and terms used for the operators so that it is easily understood. And then, as part of the process, we need to eliminate alarms from the alarm management system. What we found is normally the alarm systems are not tackled at the design stage. So we'll end up having events as part of the alarms. Events means anything that is manually initiated and actions, like an operator stopping a pump. That the pump is stopped on purpose, so we're not supposed to generate an alarm for anything that is done on purpose. And based on that, switch of a controller, for example, from the auto mode to manual mode, that's an action done by the operator intentionally, so that doesn't require to be initiated as an alarm. Prioritize. Prioritize is a vital weapon for the operators and the alarm management systems. One of the problems that was found during the investigations and all the accidents I listed in the first slide was the operator had no means to distinguish between what's important and what's not important. Everything appeared as high priority, and everything was generating so fast. So the operator had no mean to make out where to go first. So this prioritized process will help to decide which alarm to address first. And normally it has 3 to 4 priorities. And the recommended percentage of distribution will be 80% for low, 15% for medium, and 5% for high, which is totally against what I'm showing in the pie chart here. And normally the best practices are targeting both the designers, the developers of the alarm management systems, and the operators. So if, for example, a company is going to buy a third-party alarm management systems, they have to make sure that the alarm management system is complying with whatever is stated in the standards, which is one of them is having the capabilities of shielding alarms. Shielding alarms is the process of temporarily preventing nuisance alarms from being displayed for the operators. That is, the operator will have the facility to remove an alarm which is not related to the disturbance to the process now or of a lower variety, and they can be attended later. Put it in a shelf, and normally shelves come in different categories, like you may have in one-shot shelf or continuous shelf based on the conditions you set, and this allows a faster access to the critical alarms. Sorting and filtering also is one of the best practices. Is you can set filters so that you can segregate the high priority, medium priority, and low priority alarms, and you will always be able to sort them as well in the orders they appeared. Suppression refers to the generation of alarms that is preventing the out-of-service equipment's alarms from appearing to the operators. Sometimes you, for example, in the big companies, I think Babco and Benegas here as an example, we may have systems that can generate, for example, 15 alarms, but the system is out of service and it's under maintenance. So as part of the maintenance, if they will be doing the loop checks, the panel operator will be flooded with alarms and he has no action to take. The equipment is already out of service. So one of the best practices is to suppress these alarms by assigning these alarms into a group. And those alarms will automatically be removed from the display, so they will not be part of the, they will not clutter the display of the operator, and he will have a cleaner display and faster access to the alarm management, the most important alarms. Eclipsing also is another part of the best practices. Eclipsing refers to the grouping of number of alarms under one header. So the operator will only look at the last instance of the alarms, and it doesn't have to worry about what happened earlier. And the third step is to audit. Auditing an alarm system, which we have not done yet in Benegas because we are still in the phase of setting the philosophy, will certainly improve and allow you to measure how are you moving in the implementation of your alarm management systems. And it emphasizes that alarm management system is not a one-time process. Now in Benegas, what we are hoping in the end of this implementation, if we do it successfully, then we hope that we'll be complying with the best practices and standards. We'll be able to improve the safety measures, and we will be having a better operation. We'll have improved production, since we will not be activating the emergency stops or devices, and improved human performance and reduced operator loads and improved shift turnovers. Thank you very much.